Hey guys, welcome back to Algebra 2. Today we are covering chapter 7.4, Properties of Logarithms. So, we are going to learn properties of logarithms and apply it to solving and simplifying expressions. Okay, so let's get started. So properties of logarithms, you're going to see these throughout the remainder of the chapter as far as just manipulating and solving and trying to solve for x or simplifying, but you're going to use these properties throughout the remainder of the chapter. So we can look at the characteristics we've kind of used in previous aspects of math, so I think you'll be great. So for any positive numbers, m, n, and b, where b does not equal 1, the following properties apply. So if we have the product property, so if we have log of base b is multiplied n times n, what we can do is we can separate that. So if we have two things that are being multiplied together with log base whatever it is, we can separate it to say log base b, so same base of m plus log base b of n. So if these are multiplying, we can separate it by addition, okay? Quotient property, which means division. So if we have something with log base b that's m divided by n, we can separate this by subtraction, okay? So we have log base b of m, which is our numerator, minus log base b of n. Okay, so quotient would be separated by subtraction. And then lastly, power property. If we have log base b of m raised to the n power, we can't have log base b or anything with something with the exponent. So this exponent here is just moved out front here. So if you see log base b of n to the nth power would equal n times log base b of m, okay? So your exponent just comes out front. And that's how you expand that. So you can use these three properties to simplify or expand. So you can use it to simplify or to make it larger. So you may have to go from here to here or here to here. So let's use these properties to look at the problems. So simplifying. So again, this I would kind of keep at the back of your head. I mean, if we think about it, whenever we dealt with exponents, whenever we multiplied two terms, we add the exponents. So same thing here. Multiplying is like addition. Quotient, if you have, you're dividing two things, you subtract your exponents. So quotient, subtraction, those go together. And then the power property, we just can't have an exponent, so that's kind of new, but it's just brought out front. So it's super easy there. So what is each expression written as a single logarithm? So with this, we have log base 4 of 32 minus log base 4 of 2. So with these, you have to also watch whenever you can simplify if possible. So since this is subtraction, we are going to go from this to this. So subtraction goes with quotient or division. So they both have log base 4, so we can put that together to say log base 4 of 32 divided by 2. Okay? So we took this and put it together as a single logarithm. So now we can look at 32 over 2. Well, that simplifies to be 16. So we have log of base 4 of 16. Well, we can simplify that more. If we think of what we did yesterday, log base 4 of 16 is equal to x. So if we, did our circle, we had 4 to the x power is equal to 16. Well, this would be 4x is equal to, if we put this in terms of 4, this would be 4 squared. So therefore, x is equal to 2. So this, we can rewrite, 16 is the same thing as 4 squared, which this simplifies to just be 2. Okay? So that is how you work that out. So let's look at another example. So if we have 6 log base 2 of x plus 5 log base 2 of y. Okay, so it's expanded, we're going to put it as a single logarithm. And we can do that because they're both log base 2. So this 6 out front and this 5 out front, those are actually exponents of these. So first thing that I'm going to do is I'm going to take this 6 and rewrite it as an exponent of x. And then 5 is our exponent of y. So, and that's what we did here. So log base 2 of x to the 6th power plus log base 2 of y to the 5th power. So now we can put them together. Since it's addition, we know that's multiplication, so power property. So all we need to do is multiply this number times this number. Well, by doing that, it's just log base 2 of x to the 6th, y to the 5th. That's as simplified as it can get. Okay, let's look at 2 more problems. So we have log base 4 of 5x plus log base 4 of 3x, okay? There's no exponents, we don't need to move anything there, and this is addition, so that means I'm going to multiply 5x times 3x. So we have log base 4, and then 5x times 3x. Well, 5x times 3x would be log base 4 of 5 times 3 is 15, x times x would be x squared. Okay, I can't write 15 as a power of 4 or a base of 4, so that would be your answer. Okay, now let's look at B. So we have 2 log base 4 of 6 minus log base 4 of 9. Okay, so first we have a 2 here. So this 2 needs to be an exponent of the 6. So we have log base 4 of 6 squared minus log base 4 of 9. Okay, 6 squared is 36, so I'm going to go ahead and do that. So log base 4 of 36 minus log base 4 of 9. Okay, so now they're both log base 4. It's subtraction, so that means quotient division. So we have log base 4 of 36 over 9. Well, what is 36 divided by 9? That is 4. So we have log base 4 of 4, which log base 4 of 4 is equal to 1. Okay, so that is expanding and going to a single. Now let's practice if we have a single and expanding it. So here we have log base 4x divided by y. So this is quotient, so we're going to separate these with subtraction. So log base 4x divided by y, they have no base, so we don't have to put a base with our log. And so we just take our top, which is 4x, so log 4x minus log of y. Okay, now we can go one step further, because what is happening between the 4 and the x? Well, that's multiplication, right? That's not 4x, that's 4 times x. So what we need to do is actually separate this out too. Okay, so log of 4 times x would just be log of 4 plus log of x, and then minus your log of y. So this right here separated to this. So now we have log of 4 plus log of x minus log of y. That would be your final answer, okay? So B, let me erase this so we can still see that. So B is log base 9, and then x to the 4th divided by 729. Okay, so we can separate this out. So we're gonna take our top and it's division, so that means subtraction. So we have log base 9 of x to the 4th power minus log base 9 of 729. So I just broke this up into 2 by subtraction. Okay, now this right here, we can't have an exponent there. So this 4 goes out front. So this simplifies to be 4 log base 9 of x minus log base 9 of 729. Great. We can rewrite 729 as a base or a power of 9. So we need to do that. So 729 is the same thing as 9 cubed. So log base 9 of 9 cubed would be our 3. Those kind of cancel out, so we have 3. So this simplifies to be 4 times log base 9 of x minus 3. And that would be your answer. Okay, let's look at 2 more examples. So we need to expand. So first, this is division. So that means we need to separate by subtraction, okay? Our base is 3. So we have log base of 3 of our top, which is 250, minus log base 3 still of our bottom, which is 37, okay? You cannot rewrite 250 as a base of 3 and same thing with 37. So that's your answer. That's as simplified as it gets. Okay, now let's look at B. So we have log base 3 of 9x to the 5th power. Okay, so what's being multiplied here is the 9 times the x to the 5th power. So let's expand this. These are being multiplied. So we expand it with an addition sign or the addition property. So our base is 3. So we have log base 3 of the first term is the 9 plus log base 3 of x to the 5th power. Okay, we can simplify both of these more. So 9 we can write as a base of 3, right? 3 squared. So this is the same thing as log base 3 of 3 squared plus this 5 can go here, can't have an exponent. So this would be 5 log of 3 to the x, sorry. So 5 times log base 3 of x. So this one is done. However, this one we can simplify more. The log base 3 of 3 kind of cancels, so we have just our 2 plus 5 times log base 3 of x. And that would be your final answer. Cool? And so now let's look at the change of base formula. So this one you're going to need your calculator. You can use Desmos. So your change of base formula is if you have log base b of m, this is the exact same thing as if you need to separate it of log of m divided by log of b, okay? And so you need calculators. So all we're doing is, if you think about it, your log base b of m, that your m is kind of above b, so think about that like as a fraction. Your m is on top and your b is on bottom, and you literally just put this into your calculator as a fraction. Log of whatever m is divided by log of whatever b is. So if we look at this example, so we do log of base 81 to 27. So we go over here, the 20, and this is, if you look at your, like a fraction, your 27's on top, 81's on bottom, and that's how you set up your fractions with the logs. So we have log of 27 divided by log of 81. Put this in your calculator, or you can do, you put in your calculator and you get 0.75 as your answer. Okay, I think we have some more that we'll do that will actually show you how to put in our calculator. Okay, we have 3 examples. So we're going to use a change of base formula. And so if you see here, it's like if you have log base 5 of 36, you see that 36 is above the 5, that's how we write our fraction out. The 36 goes on top because it's bigger and it's above it. That's how I always remember it. So we have log of 36 divided by log of 5. Okay, so let's go to our calculator. So we have, so this is Desmos. If you go to function, here's log. I'm going to actually go back and I'm going to hit fraction. So that way a fraction pops up. And then I'm going to go to function, and I'm going to say log of 36. At the bottom, we're going to say log of 5. Okay, and we get 2.226565. So 2.227, I don't know what we want to round it to. Let's round it to the 4 digits. So we have 1, 2, 3, 4 there. The 6 rounds this up, so it'd be 2.2266. So 2.2266. Okay, same thing with this one. We have log base 8 of 32. And the reason why we're doing this is because these aren't log base 10. That's like your log base 10 is how you can find it. But if we need to find what the actual number is, this is why we use the change of base formula. So we have log of 32 over log of 8. So we put that into our calculator. So I'm just going to come up here and delete log of 32 and 8, and we get 1.666667 repeating, or 1 2/3. I'm just going to say 1.6667. Okay. And then our last one, we have log base 4 of 18. So our 18 is on top. Log of 18 over log of 4. And that's exactly what we typed into our calculator. Log of, delete, 18. And the bottom is 4. And we get 2.0849, so 0.0850. 2.08, sorry. So 2.0850. And that's the change of base formula. It's super simple, super easy. and that's how you find it a log if it's not of base 10. That's why we have to use the change of base formula, because these are not log base 10, so we can't just easily enter into our calculator. Okay, so that's it for today's lesson. You have 10 total questions in MathXL, so go ahead and get started and let us know if you have any questions.